Hello, my name is Jack Grant, and this is my athlete monitoring and coaching technology module assignment. So, a bit of an introduction. The sport that I chose was rugby union. The athlete was an 18-year-old male winger who played under 20 level amateur. So, the outcome variable is in-game maximal speed. The assessment structure used quantitative analysis to identify the outcome variable and then measure and profile it using testing and that normative data comparison. Determining factors were identified through the use of a theoretical model. These were then also measured and profiled through testing and normative data comparisons. And then there was research done to find evidence-based practice to implement in a 4-week program. This was then all reevaluated by testing to see if there was positive or negative results and why. So starting off with the outcome variable, we had, as I said, in-game maximal speed. So the importance of this to performance is that it is one of the most dominant motor qualities needed for rugby. And this is because it allows athletes to create line breaks, cover the backfield, and also in defensive line speed. And it's important in particular to wingers and outside backs because they have the highest amount of high speed running volume with 583 meters. And this has to be taken into consideration when programming is done and add that extra bit of volume, that sprinting volume for those outside backs. Onto the key dependent variable rationale. So as I said, we identified our key dependent variables through the use of a theoretical model. So training was used and identified as the easily modifiable factor, and the modes of training were plyometric training and resistance training. So plyometric training to improve that ground force production and resistance training to improve that acceleration. So onto the methods, mainly focusing on the reliability and validity of each test and technology. The stopwatch was questionable due to the potential for human error. It was also questionable depending on the operator's skill level. So fortunately, I'd done this sort of testing before with stopwatches for 10 and 20 meter sprints. So the tool was used. However, it was only used because it was the only readily available tool. If I could have got speed gates, they would have been the preferred tool and technology to use. The force plate was accurate in testing, and it tested that jump height that force produced in that stationary position. So the 10-meter sprint was also very accurate, and it captured that initial 10-meter acceleration phase, while the 20-meter sprint was also reliable and consistent, and it catched that more maximal sprinting phase and that outcome variable in comparison to the 10-meter sprint catching that key dependent variable. Another key dependent variable was our CMJ with consistent results, capturing that force production, and our drop jump capturing that more reactive force production under that high eccentric load from that drop. So here we have our outcome variable initially. So this is our pre-test data of 3.22 seconds compared to our normal data of 3.12 seconds. And this was taken from athletes of a similar anthropometric qualities, amateur, same age, same weight, etc. And on to our key dependent variables here. So we can see that our 10-meter sprint, 1.88 seconds, in comparison to that 1.80 normative, it is a weakness, as well as our outcome variable, and CMJ and drop jump are also below those normative standards. So we have our spider diagram here. We are the orange. This is where we are. The black lines are those normative standards. So by the end of this, we'd like to be at those values and at that normative standards in all three regards. So evidence-based practice, as we said, we used our resistance sprints as our mode of training, as our key dependent variables to improve that outcome variable. So we use this because weighted sled pulls were seen to demonstrate improvements in that 10 and 20 meter sprint times. This is through enhanced force production. So that's the ability of the muscle to generate that force during the movement, and also enhance that ability to develop and maintain velocity, which in turn improves acceleration. So that's increasing that speed from that stationary position that we're targeting here. Also plyometrics, so the use of depth jumps, bound, box jumps, reactive and single leg variations also are seen to decrease those sprint times. And that's through similarly improving acceleration, also explosive strength, so that obviously the plyometrics require rapid and forceful muscle contractions, but also that reactive ability. So also in plyometrics, we have those quick transitions between muscles, shortening and lengthening. This is our plyometrics here. So moving on to our programming, we started off with simple plyometric training of 3 sets and 10 reps, depth jumps, bounding, box jumps. We started off with our resistance sprints, 20-meter sprints, and we chose 10 kg for the initial cycle. We progressed the plyometrics by adding a rep to have that clear progression onto the next week, and the resistance sprints just added 2.5 kilos every week we progressed. So onto our week 3 advanced plyometrics. We now went to weighted depth jumps, single box jumps, and bounds, but we increased those reps also. So just to ensure there was no regression and just a clear linear progression as we can, especially because it's only a 4-week program. We're trying to have that volume onto the athlete and that sort of clear progression as much as we can. Also increased our sprints by another 2.5 kilos. As I said, that's just a clear linear pathway there up to 17.5 kilos in the final session. And then we moved on to progressive plyometrics. So that's reactive exercises. So all the exercises we did, box jumps, depth jumps, bounds, but we just added that quick rebound. And we also added an extra rep to ensure that extra volume, that extra stress for the athlete to progress. So post-test data and interpretation of results. So we have our chart and our spider diagram here, or our table and our spider diagram here. So acceleration was improved by 5 seconds, as we can see, just above the normative data now. And our CMJ increased by that 3 centimeters to leave it on par with our normal data, which is what we were looking for, and that drop jump just below. So this is where we are now. As I said before, we were trying to target being in line with those normative data values, and now we are successfully in line or very close to in line those pieces of data. So as a result of all those key dependent variables improving, our in-game maximal speed improved. So we started off initially with our 3.22 seconds, that pre-test data, and then we progressed to that 3.15 seconds, and that was a result of our plyometrics and a result of our resisted sprints. And that left us just 0.03 seconds from that normative data. So we are also on our outcome variable as well as our key dependent variables very, very close to our normative data. And our conclusion, so positive changes were observed across all the key dependent variables. So our use of that evidence-based practice was successful. And as a result of those key dependent variables positively changing, overall, our in-game maximal speed, our outcome variable, positively changed as well. So it's a direct correlation between them. Limitations that have to be mentioned. Maximal sprint speed wasn't fully captured. This is obviously due to maximal velocity being at about 50 to 60 meters, but more in-game realistic max speed was captured, as backs or wingers in specific generally reach that top speed and only get the opportunity to reach that top speed at 10 to 20 meters. They're not going to be running 50, 60 meters straight in the game most of the time. This was also only single jump and sprint assessments. So the athlete, of course, did their sprint, did their jump, then they got a rest and recover, and then they went again. In a game, of course, they're not going to be able to do this. They're going to have to sprint. They're going to have to jump without any recovery, and the time is going to be unknown between these. So a recommendation that could be said is to have another day where multiple jumps are tested to test that repeatable sprint and jump ability. The use of a stopwatch is also, of course, a limitation. The potential human error and also that operator skill, as was mentioned, and also force play pre-test unfamiliarity and also post-test. So pre-test, the athlete never used a force play before, and I could tell that their jump mechanics were very different to what I'd seen in a game or in the gym in general. Which maybe led to a slightly skewed result pre-test, and then post-test, the fact that they were familiar, they were jumping more comfortably, which could potentially have aided in them getting a better score. So these are my references. Thanks very much for listening.